An overview on algebraic identities 5, 6 and 7. Let's look into the identity for the square of a trinomial. It is identity 5 and it goes as a plus b plus c the whole squared is equal to a squared plus b squared plus c squared plus 2ab plus 2bc plus 2ca. There are some variations to this particular identity where either one of the variables or one of the terms or more than one of the terms can carry a negative sign, and the identities I have mentioned it under some special cases of identity 5. Now this type of identity, that is the square of a trinomial, is entirely different from resolving a trinomial like the given mentioned problem indicated by the red color, wherein we need to make use of identity 2, and the answer will be a minus b the whole squared plus a minus c the whole squared plus b minus c the whole squared. If you look into the question of this particular problem, the terms which include the products like 2ab, 2bc or 2ca, they all carry a negative sign. But if in case it has to come under identity 5, either 2 of these multiple terms or one will carry a, or all the three will have a positive sign. These type of sums come under identity 5, and if all these product terms have a negative sign, then we need to resolve it under identity 2. One more hint which we can make use of is, if you look into the coefficients, all the coefficients are the same. It is for this particular sum, it is 2 throughout. Now let's look into some problems which make use of identity 5. Look into sum number 1, 9x plus 2y plus z the whole square. Just replace the given values onto, just map it onto the identity 5. Then replace the values onto the identity 5 expression as a squared plus b squared plus c squared plus 2ab plus 2bc plus 2ca. Then you get the resultant. Same for question number 2. Just identify a as 2a, b as minus 3b, c as minus 3 minus c. Just replace the value in the variables and then you get the resultant. Let's look into a more difficult sum on identity 5. Till now we have seen only one expression and you just have to resolve replacing the values. Suppose we are given, if you look into the sum number 1, it is 3 different trinomials with the operators separated. So the first sum is a plus b plus c the whole squared plus a minus b plus c the whole squared plus a plus b minus c the whole squared. Each one of these 3 terms of or expressions will satisfy identity 5, resolve each one of them separately and then get the final resultant. Similar case with sum number 2, wherein the signs in between the trinomial expression is different, so we need to treat it accordingly. So if you consider the first expression as E1, second as E2, third as E3, the given sum can be represented as E1 plus E2 minus E3. Remember to carry the minus sign of E3 into the expression when resolving it and you get the final answer. These set of sums give the values of certain expressions which can fall under identity 5, and then they'll ask you to find the value of some expressions like AB plus BC plus CA or A squared plus B squared plus C squared, or terms or a plus b plus c. So depending on the what is being asked, you just have to identify that all these expressions will come under identity 5 and then replace the given values and find out the expression which is being asked for. So looking into the very first sum, it's a squared plus b squared plus c squared is 20. And a plus b plus c is equal to 0. Find ab plus bc plus ca. It's a very simple sum wherein we just have to replace the values given. And you need to find the value of ab plus bc plus ca, which you can very well look at the expression and find out. Looking at sum number 2, the given values are a plus b plus c is 9 and ab plus bc plus ca is 40. We need to find a squared plus b squared plus c squared. Immediately it is the right hand side expression which is being asked for. Replace the values and get the value which is being asked for. Third sum is similar. A plus b plus c is 0 and a squared plus b squared plus c squared is equal to 16. And ab plus bc plus ca is the one being asked for. Replace the values and get the resultant. Fourth sum is also a similar construct. Given the values of the entire right hand side of the expression, they've asked the value of a plus b plus c. The left hand, remember to look at the left hand side of the identity. It is a square, but the asked value is not a square. It's just a plus b plus c. So we need to remember to find the square root of the given of the value or the resultant that is obtained after substituting, and remember to put a plus or minus symbol to the final value so that you will get the value of a plus b plus c. The next sum is also a similar sum wherein left hand side of the expression is given. Just have to replace it, put a square. The half of the right hand side of the expression is given and the other half is being asked for. Just replace and find the resultant. Let's look into the identity for the cube of a binomial. Identity 6 and 7. Identity 6 is a plus b, the whole cube is a cube plus b cube plus 3ab times a plus b. Identity 7 is a minus b, the whole cube is equal to a cube minus b cube minus 3ab times a minus b. So these are the set of sums which can make use of the identity 6 and 7. Just replace with the given values and you'll get the resultant. Let's look into these kind of pattern of sums wherein one variable is x, the other variable is 1 by x. For this slide and for the next slide, given is the value which incorporates a lower power variable in the expression, and what is being asked for is either the square or raised to the power of 3 or to the power of 4. So given a lower power and asked for a higher power, let's see how we'll go about these kind of sums. So you need to find what is being given and what is being asked for. The given sum, the operator is being used as plus in both the given as well as for the asked expression. So we need to go for a plus b the whole squared. Just replace with the values and then you get the final resultant. It's a very simple sum. And for sum number b, you need to use the value of x squared plus 1 by x squared in the expression of x to the power of 4 plus 1 by x to the power of 4. So this you need to find the square of it, wherein in the resultant you will get the expression going as x to the power of 4 plus 1 by x to the power of 4 plus 2 times x to the power of 4 into 1 by x to the power of 4. So just replace with the values and you will get the value of x to the power of 4 plus 1 by x to the power of 4. Similar case with sum number 2. If you look into sum number 3, there is a difference in the operator. In the given expression, the operator used is minus, whereas what is being asked for is a plus. If there is a minus in any one of these, you need to use the identity which involves the minus sign. X minus 1 by x the whole square, and then you go about substituting the values and you get the resultant. So the sum number 4 is also a very simple expression. Just replace with the values and you get the. These are a set of sums where the degree of the given expression will be 1 and being asked for is x cube. So how do we go about? Like the given degree is smaller than the degree of the expression which is being asked for. So immediately you write the formula or the identity of the expression that is being asked for. And then replace the values. X plus 1 by x, the value is given as 7. So the expression also goes as a plus b the whole cube is equal to a cube plus b cube plus 3ab times a plus b. We have the value a plus b. So the left hand side of the equation as well as the right hand side of the equation, you can replace the expression with the value of 7. Resolve it and then you get the value of a cube plus b cube. Similarly, for sum number 6, the operator is minus, so we have a different identity for it, a minus b the whole cube, which is equal to a cube minus b cube minus 3ab times a minus b. Just replace with the given values and then you get the final resultant. Same with sum number 7 as well. Now, if you look into sum number 8, the given expression has a positive operator, the one being asked for as a negative operator. So, we need to make use of the expression. This is a two-step sum. Like what is being given is x squared plus 1 by x to the power of 2, which is equal to 83. But what is being asked for is x cube minus 1 by x cube. If you look into the expression of x minus 1 by x the whole cube, we need the value of x minus 1 by x. So, how do we derive the value of x minus 1 by x? If you double it with the given, that is x minus 1 by x the whole squared, then you get the value of x squared plus 1 by x squared minus 2 times x times 1 by x. So, in this way, we can derive the value of x minus 1 by x and then replace this value onto the expression for x minus 1 by 3 the whole squared and get the resultant. Similarly, you need to work out on sum number 9 as well. This particular slide shows you in case the given binomial has a higher power or a higher degree and you are expected to find the value of a lower degree, then how do we go about? So looking at sum number 10, it is x squared plus 1 by x squared is 27. We need to find x plus 1 plus y, 1 by y and x minus 1 by y. Since looking into sum a, it is x plus 1 by x. The operator is plus, so you make use of the first identity and then replace the values, you get the answer. X minus 1 by x, you make use of identity 2, extrapolate the given expression, write down the formula, replace the values and you get the value of x minus 1 by x. So, initially we get x minus 1 by x the whole squared. Then you need to find the square root of it. So, remember to put the plus or minus sign when you are finding the square root of it. Looking at sum number 11, if x plus 1 by x squared is equal to 66, find the value of x minus 1 by x. So, if you look into the given values and what is being asked for, one carries a negative sign. So, you will make use of identity 2. Just write down the identity, substitute the values. You will get x minus 1 by x the whole squared value, the square root of which will give x minus 1 by x. Now, looking into sum number 12, if x squared plus 1 by x squared is 79, find x plus 1 by x. It's the same procedure. Just write down, since it is x squared, write down identity 1, substitute the values and you will get the resultant very easily. Now, sum number 13 looks a bit different. If x to the power of 4 plus 1 by x to the power of 4 is 47, how do we find x cube plus 1 by x cube? So, in order to resolve any sum, just pay concentration or attention to the given set of values as well as what is being asked for. What is being asked for? It is x cube plus 1 by x cube. So, this will come only in the formula for x plus 1 by x the whole cube. So, we definitely need to reach the value of x plus 1 by x. How do we reach? We just have x to the power of 4 plus 1 by x to the power of 4. Now, if you write down the expression for x squared plus 1 by x squared the whole squared, we can immediately replace the values of x to the power of 4 plus 1 by x to the power of 4, whereby you will get the value of x squared plus 1 by x squared. This is step number 1. Having got the value of expression x squared plus 1 by x squared, we can very easily, in the same way, find out the value of x plus 1 by x, and hence you can just replace the values, you will get the resultant.